Hi, so we're the 5G group. It's Hunter Jasinski.
Tim Jaeger.
And Caleb Hunter.
All right.
So what is 5G? The first question you may have when you see the term 5G is what exactly is 5G? Simply put, 5G stands for 5 generation, as in the 5th generation of mobile broadband technology. It is the newest group of industry accepted standards for running cellular networks. This current generation that most of our phones use today is actually 4G, which is a group of standards before 5G. 4G and 5G differ in many ways, but we'll get into that later into the slide. Now, 5G promises to provide much more performance than 4G, as well as lower latency. Now, the history of 5G. 5G networks are the next generation of mobile internet connectivity, offering faster speeds and more reliable connections on smartphone and other devices more than ever. Combining cutting-edge technology and the latest high-specified devices, 5G should offer connections a higher abundance of faster than previous mobile technology, with average download speeds of around 1 gigabyte per second expected to be norm across many next-gen networks. The networks are also expected to accelerate IoT, or Internet of Things. This provides the infrastructure needed to carry huge amounts of data that would enable a smarter and more connected world. These networks were launched across the world by providers offering connectivity across the US, the UK, Australia, as well as other countries around the globe. And Verizon surprised most of the world by launching its 5G home network after launching its 5G network in 2018, which was late 2 years ago. Now here is a chart that demonstrates the evolution from 1G to 5G. So James Clerk Maxwell in the 1980s discovered electromagnetic waves and suggested they could travel at a speed close to that of light. Not long after, Heinrich Hertz found a way to produce and detect electromagnetic waves, which are now today called radio waves. The discovery of these new waves allowed bright minds during those times the thought of using it in information carriers such as cell phone companies. 2G, the second evolution of telecommunications technology, was created after 1G. 1G, if you think about it, was like those big block cell phones that you could carry a brick with an antenna. And it had about 200, and it could transmit on 250 kilobytes per second, which was not that much. So the connectivity was kind of terrible. That's why you had those super long antennas that you had to pull out. It looked like a radio. Unlike 1G, 2G uses digital signal transmission rather than analog of 1G, and had a theoretical bandwidth of 50 kilobytes per second to 1 megabyte per second, respectively. 3G was then introduced in Japan by Nippon Telegraph and Telephone in the early 2000s, and there wasn't much improvement over phone calls and messaging. However, 3G outperforms 2G in that category of being able to, from the improvement of phone calls and messaging. 4G was then created in 2009 in Oslo and Stockholm, which was commercially known as LTE. LTE provides significantly faster data speeds with downloading cap of over 100 megabytes per second and uploading cap of 50 megabits per second. The most important improvement besides security and encryption was the latency of 4G. Now, what is the massive IoT network? Now, massive IoT is basically a huge network of physical devices that are connected to communicate with each other. They're constantly transferring data to and from one another. They allow machine-to-machine communication. They have a lower latency and a low latency response time, and they have a high uptime. Now, the translation from the simple machine-to-machine connections to the to the complex Internet of Things is underway. This is improving LTE and creating 5G networks to enable faster connections and higher bit rates. Critical IoT requires low latency and high uptime because they are data-rich applications that are bandwidth hungry.
This is Tim Jaeger again. So now that you have a little bit of an understanding on the history of where we are on mobile communications, now we're going to get into how 5G actually works. And we're going to start off by doing that with infrastructure. So IT infrastructure is the main backbone of the telecommunications industry. The media communications rely on cell phone towers and the software to run networks and mobile towers. This tends to be the actual physical towers, the people working on the towers, and all of the software that went in to develop the programs to enable cross-country calling. The 5G spectrum will be lower than the 4G spectrum, and it will also use different frequencies. When it comes to 5G and 4G, they will both be using similar frequencies, but 4G will still be the main priority as 5G is still continually being rolled out. And one of the main fundamentals of the 5G hardware and software infrastructure is MIMO, which will be covered later on, but is pretty much a radio link for multiple incoming and outgoing media transmission using antennas. And as said previously, these frequencies will be reusing some of the 4G technology with a little bit of a difference with the hardware. So looking at the power consumption from 2G to 3G to 2G to 4G and then 5G currently. So 5G requires a lot of power consumption. This power consumption will put more stress onto the power grid. And as you can see from this chart that's listed here, there's a 68% increase from the current baseband unit. That's a very big increase for such a small period of time. But with all the capability that 5G has, this is a requirement. The gradual increase of power usage that different generations take, so each generation has a new hardware and software requirement that will require a power increase, which is why you see a 43% increase from 2G to 3G to 4G. The computing resources help keep the connection stable and with low latency require a lot of power, but it will also increase prices on consumers looking to join the 5G standards. The higher the number, the higher the power usage. The power consumption is required to run all the new technology. So according to one of the articles quoted in this presentation from Fierce Wireless, exact estimates differ by source, but the MTN said that the industry consensus is that 5G will double to triple energy consumption for mobile operators once a network scales, and this is from Larissa Hardsley. And she is trying to just pretty much put into the point that as we continue to move into the higher generations, we will continue to see more and more power consumption, and these companies will have to find out a way to cut back on those energy consumption costs, but as well as providing a stable and reliable service to consumers. So now we have a little bit of a comparison from our current 4G standard to the 5G standard. So 4G pretty much operates on a core that then gets split up into many dedicated access wireless or wired lines, which then will be transmitted to the front hall, which then will be spread into radio waves to the different devices that you may tend to use. The difference with this big 5G network is that the 5G is more reliant on cloud services, and it uses and 5G also uses many backbones of 4G networks that we still use today, which will be very important coming future. The hardware it's all focusing more on distributing the core 5G services with the current hardware we have through many different links. So as you can see in this picture above, there's a central cloud that tends to host all this information, and then it is distributed almost like a 4G link, and then it is then distributed to devices through radio waves, as said previously, like MIMO. So this is, there are many different ways that 5G network can be implemented. So this is one variation of a 5G network deployment. Each deployment or have a different type of node connection that a 5G provider can offer, and I'm going to break down this picture for you. As referenced earlier, MIMO is the one-way telecarrier can broadcast 5G signals. It would be done through nodes on top of network power tool that you can see on the left-hand side. And they could be grouped together to create a stronger connection between the nodes and have faster download speeds. The nodes would also use D2D or device-to-device connection, which is how many mobile connections can have a secure connection without having to use a base station. Another route that a telecommunication company could take, it would be to share the connectivity via a spectrum sharing. This is a method where the nodes and the cell towers would reuse older hardware and software with updates to each of the programs. Then they would allow for new 5G connections to occur by piggybacking off of the existing hardware. And the users would then be able to use multiple different frequencies of 5G and 4G without having a massive throttle in speed or usage. This process would use machine-to-machine learning communication using wireless or wired connection with the hardware that telecarriers have access to. And then this can either be with sensors or AI. So you can see on the right-hand side, they can use mobile-to-mobile connectivity to have a broadcast 5G link. And finally, we're looking at the infrastructure, we have to talk about the economics. So this is going to be a very expensive deployment. When we were rolling out 4G, there was a lot of new infrastructure that had to be built. And with all this hardware, software, money, and finances play a big role into the deployment and maintenance of this new generation of technology. Obviously, there's going to be some big costs that telecommunication companies are going to have to make to be able to deploy and implement the technology to their customers. And that starts with the hardware. So the hardware starts off with all the antenna nodes that need to be attached to top of telephone pole. This is the primary way that 5G will be rolled out across the country. These nodes need to be developed, installed, updated, and have um, consistent maintenance on to where whether it be a weather or just a general malfunction. This happens frequently depending on the location around the world, which then leads to my next point of having to constantly update the software and hardware. As 5G is so new, the main focus of the 5G boom would be the hardware that is required. So as this is so new, there's still going to be a lot of bugs and things that had to be worked out to deploy specific software to be used on cell phones and hardware with certain cell phone devices to be able to use 5G. So the software would have to be monitored and issued patches for whenever the bug or exploit that could be found, which could exploit the network in some way. And I just want to insert a note here that 5G does not cause coronavirus, no matter what anyone says. That is a false rumor. And all the additional hardware software requirements would then need some maintenance to be done. And this maintenance, as said, would have to be done by technicians that telecommunication companies hire and employ. And they would need to be trained and tested to make sure that they can handle the new technology and to install this new technology. And with these 5G speeds that we talk about, there's going to be different price points depending on which frequencies that a customer may use their 5G services on. So depending on the infrastructure that these telecarriers deploy and how they implement their 5G in certain areas across the nation, there's going to be different price points for all of these different speeds that a telecommunication company would be able to offer.
All right, so this is Hunter, and I'm going to talk a little bit about the different technologies that go into 5G. The first one being NR, which stands for New Radio. NR is the standard that defines how the new radio frequencies that 5G will use. The third generation partnership project, or 3GPP, is a group of standards organizations originally established to create the standards for 3G. 3GPP is still active in creating standards, and they established the frequency ranges for 5G. They established two different frequency ranges. The first one, frequency range 1, is called the sub 6 gigahertz frequency range, and it operates between 450 megahertz and 6 gigahertz. Frequency range 2 is called the millimeter wave frequency range, and it operates between 24.5 gigahertz and 52.6 gigahertz. These frequencies, especially the millimeter wave frequencies, will operate at higher frequencies with lower wavelengths than what we're used to. This will reduce the effective range of each cell tower, resulting in an increase in the number of cell towers needed to support mobile networks in the future. MIMO is another 5G technology. MIMO stands for multiple input and multiple output. It means that there are multiple receiving and transmitting antennas operating at the same time. MIMO increases the effective capacity of each cell tower by adding these extra antennas. MIMO allows a base station to send multiple signals at the same time to the same destination. This is permitted by exploiting a phenomenon known as multipath propagation, which I'll be explaining on the next slide. MIMO allows for higher data transmission rates than what we're traditionally used to, since multiple signals are allowed to be transmitted at the same time. This effectively increases the bandwidth of each connection. That brings us to multipath propagation, which is what MIMO runs off of. As previously stated, MIMO exploits a phenomenon known as multipath propagation. Multipath propagation is a phenomenon that two different signals can reach the same destination via more than one path. As shown in this image, the 4 different signals can be transmitted from the transmitter to the receiver via those 4 different paths by being reflected off of different parts of the building. 5G will use this phenomenon to its advantage by using MIMO, which will be enabled by adding more antennas to base stations. MEC is another technology being introduced as 5G. It stands for Mobile Edge Computing. This concept involves moving cloud services closer to the end device. More specifically, it involves integrating cloud computing, storage, and networking resources within the base station itself. This differs drastically with how cloud servers were traditionally provided in the past. In the past, cloud services were all globally centralized within an organization's server or group of servers, and base stations only facilitate the transfer of data between the end user and that cloud server or group of servers. With 5G, base stations are expected to provide some or all of the cloud services that the globally centralized services or servers used to. The old centralized clouds will be broken up into regional and local clouds for greater efficiency. This would drastically reduce latency for end users as well as put less strain on the network, since all traffic will not need to travel from the end user to the centralized server and then back again. Central or regional clouds would also have access to base station information for use in their services. A simple example of this would be to introduce advertisements in a very specific geographic area by only allowing those advertisements to be distributed on a select few base stations. This is a very simple example, and it remains to be seen what this kind of information can mean for the future of mobile network applications. This is a simple diagram that offers a graphical representation of mobile edge computing. As you can see, the public and enterprise cloud on the right-hand side show what was traditionally the globally centralized cloud model for cloud services. These clouds will be broken up into regional in the middle of the image, and then into local clouds that are closer to the end user. Each local and regional cloud will be able to conduct its own storage and computing as needed, or pass it onto the regional cloud, which could pass on the request to the global cloud if it is still not able to fulfill the request. These local and regional clouds will also be able to cache frequently used information in order to improve the efficiency of the network. The hierarchy of these base stations will also be enabled by the next 5G technology I will be discussing, which would be SDN. SDN, or software-defined networking, is going to be a part of 5G. Like we talked about in class, SDN essentially outsources the control plane on each router to the SDN controller. Instead of the base station needing to decide for themselves where information needs to be forwarded, they'll be instructed by SDN controllers where to forward information. SDN allows for the base stations to have their own control planes programmed into hierarchies that will allow for greater efficiency within the network. Programming of the network would also enable other technologies previously mentioned. For example, the strict hierarchies SDN enables will support mobile edge computing and caching of locally popular content at a local base station. Next, I'm going to pass it off to Caleb to talk about some of the future implications of 5G.
Hello, this is Caleb here. So for the implication in the future, for the first point, 5G might not have an intermediate effect at first, as we've seen in the previous generations. We see that's going to take a few years for the mobile application developers to truly take advantage of the new technology that they have access to now. It will be exciting to see what these developers manage to come up with in the next few years, as well as the improvements to like some technologies such as IoT, self-driving cars, and smart cities. Things that are currently being implemented right now, like in Silicon Valley, Chicago. Everybody's trying to make something and be smart when they're not. The next thing is the enhanced data transfer permitted by 5G could also make standard wired networking obsolete, especially where prior wire infrastructure is not present, as the mobile networks and the traditional wired networks converge to similar data transfer rates and coverage ranges. Many could make the switch to mobile networks as their main connection to the internet. If 5G does not, in fact, reach speeds of higher than 20 gigabytes per second, that could supersede the need for traditional wired infrastructure in large urban cities like major cities. We do have yet to see what the negative effects of 5G have on our daily lives, such as private concerns, which is a very big topic. It is always a very big topic now. And one thing is for sure, 5G does not cause COVID-19. Thank you.
All right, here we have our references, references continued, and references continued. You want to look up any of our information that we use for this presentation. Thank you.